All right, students. So this question is from current electricity in circuits. And you can read the question first, and then I will reduce the size of the question. Each element in this chain, it's a finite chain. It's not infinite. There are some questions which are to be solved using the infinite ladder concept. I have done that infinite ladder as part of my playlist. Please go and watch it. So this is a finite ladder. Each element is a resistor of 1 ohm, 1 ohm, 1 ohm. The current in the last part of the final element. So the word used for this is final. The last is 1 ampere here. You have given that the voltage, the potential you applied is 30 plus n volts. This could be a voltage source. Okay, for all you know. You have to find the value of n. I hope the question is clear. Resistors are given, current is given, value of V is given in the form of n. Read the question and you have to find the value of n. I hope you have read the question, understood the question, and I will now reduce the size of this question so that I can get some space to write and solve this question. You can watch this question as is. Okay. Now, let's see a shorter way if we can, right? So I am not going to. Now, if you know this is the current 1 ampere, what is the voltage here? Okay, between these 2 points. So it is 2 into 1, right? Because this is 1 plus 1, 2 ohms. 2 into 1 is the value of the voltage across the last ladder. So this is your last ladder and the value is coming out to be 2 volts. So the potential difference here from here to here, so I'm using a different color now, is 2 volts. Right? This is loud and clear that this is 2 volts, right? So essentially the voltage between these 2 points is 2 volt. So this circuit is in parallel to this circuit as we had seen here, right? 2 ohms is in parallel with 1. So the potential across 1 ohm is also 2 volt. So therefore the current here is how much? What is the current here? If this is in parallel, these two are in parallel, the potential drop here is 2, the potential drop here is 2. So this is 2 ampere again, right? So you know the potential, you solved this, the value of potential you've got is 2 volts, this is 1, so this is 2 amperes, and this was 1 ampere, right? So you're able to find the value of the current also here. If the potential here is 2 volts, can we make a prediction? And so that means the total current which is entering here is what? We apply Kirchhoff's current law here. Okay, so 1 ampere is entering here and 2 amperes is entering here. So the total current here is 3 ampere, right? Using the Kirchhoff's current law. Okay, let's talk about, so if this is 3 amperes, what is the potential drop? It is 3 volt. So what is the total potential drop from this point to this point? 3 volts plus 2 volt. So this is your 5 volts. If this is 5 volts, 1 ohm is in parallel with this. 1 ohm is in parallel with these two. So the potential here also is 5 volts. So the current will be how much? 5 amperes, right? Which means the total current which is coming from here is 3 plus 5 is equal to 8 amperes, right? We are doing it in a reverse manner. So the total voltage drop is going to be 8 volt. The voltage drop here was 5 volt. So the total voltage drop from here to here is 13. So from here to here it is also 13 because it is in parallel with this combination after you keep on simplifying it, right? So let's talk about, this is 13 volts. So the current here is 13 ampere, and so if this is the 13 ampere which is, so what is the current entering here? This is 8 ampere and this is 13 ampere. So the total current entering here is 21 ampere, right? So what is the potential drop across this point, right? It is 21 volt. So which means the total potential drop is 21 plus 13 is equal to 30 plus n, and therefore the total is 34 is equal to 30 plus n, and n is equal to 4. 4 is your answer, right? So I was trying to do it in a parallel series circuit. We would have got the answer, but I think this was a more elegant approach to solve the question. Okay, I will just repeat what I have done. So the last ladder is 1 plus 1. Okay, look at the last ladder, this particular ladder. The total resistance is 1 and 1. The current is known, so the potential drop here is 2 volt. And now this particular resistor is in parallel with this, right? So if there is a 2 volt here, you also have a 2 volt here, right? So you have a 2 volt, you also know the value of the resistance here. So this is your 2 volt, you know the value of the resistor. So this also it becomes 2 ampere. This is 1 ampere. Okay, so which means the total current as per Kirchhoff's current law entering here is 3 ampere in this branch, right? So I have taken an approach from this side. Okay, I was first taking the equivalent combination of resistance approach, but then I decided to use my knowledge of how does the potential spread across the series and parallel resistors. So I could easily, and then of course I used another concept which is Kirchhoff's current law. So I hope you like this video. Watch this closely, see what I have done. I'm not sure if it is visible or not. I think it should be visible to you clearly. And go and see my playlist of current electricity. You will find some fantastic lectures for IIT, for NEET examination, for board examination, reasoning assertion questions, live recorded classes, and don't forget to join my community. You will see some fantastic questions coming up in the community tab, and do not miss them. You can expect a lot of questions from my community tab in your entrance examination. I know it's a tall claim, but similar questions may come because the nature of questions I'm putting in the community and the videos which I'm preparing are highly conceptual. Thank you very much today.